how to design a software? Means this question kind of it is an obvious question. Means if we write a program, then we start with the designing. Means how should I proceed writing a program? We cannot just start writing the program and it should work because we have to use on daily basis. So there should be some design. Designing can be minimal or it can be extensive. So for the long-term projects, when we design a software, then it should be intricate. And it can be coarse when it is small and less usability. So how we can design a software? What is the requirement of software? Software should eat less. Software should eat less electricity. When software runs, the the voltmeter and ammeter or power meter should show less power consumption. Okay, so this is the requirement of the software. So when we run the software, it should eat less electricity. What I mean is that it should eat less effort. Like if I design a software, then the development cycle should be less. Then number of people they are involved in the development. They should not be kind of very high salaried and then too many people and it taking long time. So it should eat less. Means the duration and the time spent and the money spent in the development should be less. Testing should be less. And then maintenance, one of the most important things. Then post-release, then maintenance of the software. That should again eat less. It should consume less electricity. And when we talk about the maintenance, not only the number of people or cost to the maintenance, if it eats less, then like the tire of a automobile, if it eat less, eat more, means it is very high width tire, then it goes away quickly. So if a software in maintenance also, if it eats more, then durability will be less. So if it eats less, then anyway food is less and durability is high. So the requirement for the software is that the effort, whatever in any coordinate, the effort what we push in, okay, the resources what we push in, so that should be as minimum or as less as possible. So that is the designing of a software. That is the pre-requirement when we design a software. Now it comes to designing. You see any book in designing, mainly they talk about two parts in the design. One is inheritance and one is containment. We should see these many things when we inherit, then only we inherit. Or these many things when we contain, then only we contain. Then in inheritance there are many things. We should go for single inheritance, multiple inheritance, virtual inheritance, or a virtual data types like polymorph. So polymorphism in inheritance or polymorphism in its member variable. So it can be function, generally it is function. So that comes in a part of inheritance. So either we should go to inheritance or we can go for containment like aggregation or composition, okay, delegation. So these are part of containment. So either we should go for containment. Like if we are kind of, if the method should be, if user is inclined to call methods, then generally people go for inheritance. Otherwise, he likes to take the content object in his own hand, then we go for containment. But anyway, these are personal. These are minimum requirements. Okay, so as things are getting complex, artificial intelligence, data science, machine learning, so these concepts are coming. So no one can afford too much paying to the employees. So things should be as smooth as possible. So what extra we do in the design? So it is called making the hierarchy. Okay, so layer based. So whatever we are thinking about the inheritance and containment, anyway it should be, it should appear, means it should be present. But at each level, I am talking about the layer design. Then it starts from the zero layer, and then slowly it moves up, and then top layer is a kind of master layer, which uses the down layer. Okay, but it is not TCP, IP, and whatsoever. So it is more active. So designing is kind of it's an active entity. It's not passive entity. Okay. Then now, if it comes to hierarchy, then what should be present at what hierarchy? Now we think when we kind of write program, then we think about what are the resources available, means granularity. What are the basic things available? Like I am making a kind of robot, okay, like a human body. Means I have bones. I have bone as the basic entity. Now, the most basic thing that I can imagine is part of the finger. Means this part, then this part, then this part. There are 3 bones. Okay. So at the zero level, we have bone. Means I can go even zero, where there are cells and then mitochondria and I believe so many things that is inside. Even inside that, someone can go and he can say that there is a neutron and proton. But still, we are at granularity level as bone. So now each part of the finger, so there are 3 entities. Okay. So at the ground level, that is zero level, then we have the actual entity as 3 bones. Now as we proceed up, then things become abstraction. So the ground level is the real entity, and then it proceeds in abstraction. So how much it proceeds in abstraction? So each layer would behave like a living entity. That is the difference between whatever we have seen, because it's the AI era. Artificial intelligence means it's intellectual. Everything should be intellectual. Okay, that passive programming is going on. Now, if I have 3 basic bones, then this finger is an abstraction on top of 3 basic bones. Finger is not an entity, means it consists of 3 parts, but all on its own it behaves as a one basic entity. The way the 3 bones are, finger is an abstract type, bone is a concrete type, then finger is an abstract type. It consists of all 3 types. Now with the thin finger and this what we can say palm, then we have kind of this area. Okay, full palm area. Okay, after the wrist. So this area is again abstraction, consists of this part and fingers. This part again has bones. So this is abstraction. Fingers are abstraction. Then bigger abstraction. So we are moving layer. Now we can think of inheritance and containment anyway. So like this part contains the bone or whatever. Or if you go down, then bone contains cells and so anyway containment and inheritance anyway there. So these are not big part to think now. But anyway, if we go for at the layer of inheritance and containment, there also we should be very clever. Otherwise, but that cleverness is minimum requirement. Now, so this is an abstract. So each layer there is abstraction. It is making bigger abstraction. This is kind of one base of the deep thinking. So we also called deep learning in the artificial intelligence. So this is where we have kind of abstraction in layers. Now this part is there. Now if I talk about hand up to elbow, then this part and this part, this is another abstraction. Then from here it contains this part and this part. This is full hand. So full hand is an abstraction. inside that we have lower abstraction. Then 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 finally we have the actual resource. Okay, so so now if I go layer up and up and up, then we come to mind. So mind is kind of the topmost abstraction, and each abstraction layer should be in position to kind of guide or conduct or make the lower layer follow its decision, any level. So if mind is the top level in the abstraction, then directly you should go to the any part of the finger. Then full finger, any part of the finger. Full finger, this part, then full hand. Means it's a top level abstraction should be able to use any portion. So these are the design requirements. Any part of the design. When how it eats minimum electricity. So that is the place we start with. That our design should eat, means software should eat minimum electricity. Now we understand the abstraction. Means all organs what we see, this is how the God made. They are layer by layer. Okay. Now the topmost is the mind. Now how it would eat, how we can make our body, it should eat minimum energy. How we can eat less and we perform more. Okay, people they eat too much, but not required that they would perform. Your design is not good. So I mean, it happens in human also. Means a lot of people they eat too much, and probably many they are kind of cancer patient and tuberculosis patient or heart patient. Still, their electricity consumption is very high. Food consumption is very high, but still they are not able to perform. But people who eat less, many people, I won't say that people who there are many people who starve, they are not able to eat, so they don't do anything. They just think about eating food. But if we go for better design, then eating less, perform more, then how it's possible? So in the designing, each entity at each abstraction layer, it should behave as a living organism. It should behave as a self brain. Okay. So like if I talk about the finger, then if I am walking and I am not aware of it, still finger should not fall off. Okay, one thing. And second thing is if something touches something get a stick to the finger, then it should automatically rub it off. I should not worry about it. I mean, this abstraction or this abstraction, if someone is touching my hand, okay, I should just wash it off. Means I should just push it off. I should not think about it. Brain should not think. It should make 99% of activity on its own. If I am walking, I am not thinking. If I am running, I am not thinking. Means brain can think something else. Okay, so if I am running, then as if I am sitting, because leg is doing its own work. Okay, without any dependency. So all the abstraction, when work is given, then they do the work on their own. They are not kind of taking energy from upper leg, or they take instruction maximum, but not the energy. I mean, there should be self-contained. Typically we say each cell, so each abstraction layer, they should work on their own. They should behave like active entity, not passive entity. Okay, then what is the role of the higher level? Higher level role is to give the instruction, signal, not the energy. They contain the energy, and 99% they should be able to take the decision and work on their own. If I talk about the physics, then it is called internal energy. So internal energy at each abstraction should be high, and so that they should be able to do their work. And what external energy they take is the signal. Okay, is the instruction. That's it. So Now, if I talk about the design pattern, so design patterns are three. One is creational, one is structural, and one is behavioral. So generally, inheritance and containment, polymorphism, and then late binding, so containment, they become part of the behavioral design pattern. But what about creational and structure? So there is a design pattern called flyweight. So flyweight is a design pattern that is most suitable. There are two parts in flyweight. Every entity in the flyweight has two parts. One is intrinsic component, one is extrinsic component. So intrinsic component is internal energy, and extrinsic component is a signal. What we pass to make the changes. Anyway, extrinsic component, if we send a signal, then anyway it modifies the internal energy states also. But still, the extrinsic component should be as less as possible. Like if my class has interfaces through functions, then a function should be minimal and it should take minimal parameter. Otherwise, it should work on its own. So only hint is required. So now brain. So this I am doing like this. Then brain suddenly says stop. So it is stopped. Now brain sends a signal to this area to do like this. Then it is doing like this. I am thinking, I am talking to you, but it is doing like this. Now this is internal component of this part. So this is working as internal energy. Now brain said that you do like this. So whatever brain is giving the instruction to this part, so that is the extrinsic component, external energy. And then to start moving like so. This abstraction layer, it works on its own, but it is kind of changeable only when it receives the signal from the higher level, and signal energy is very less. So altogether, the body runs in less electricity. Okay. Now I am doing exercise. I am doing finger like this. I am working. I am thinking. Okay. I am doing many other things also. Okay. And my brain is working. Okay. Stop. So my brain said stop. So there is a signal. Now brain should be. So this is one part of internal energy and external energy. Another part is, since brain is sitting at highest level, it should be able to control each part individually. So brain is saying this, each part, then this, then this, then this, then this, in this position, then this, then this. Okay? So each part, each higher level, abstraction level, which is an active entity, should be able to handle the individual lower level individually. Okay? But brain should not pass energy. That is the requirement. Brain should pass only instruction or signaling. Okay? So that is one part of the designing. What is the another part of that? So I believe we are done. Okay? Now, if we think about design pattern, then in creational design pattern, there is a design pattern called builder design. Now, when I talked about instruction and internal energy and external energy, now suppose we have many systems in our body, like neural network. Neural network means neurons are there, endocrine system, okay, then circulatory system, then respiratory system, okay, their skins are, I'm not a doctor, but still, means these are the systems in body. And now, for God's sake, means everyone should be healthy, hale and healthy, but there is some problem in neuron. Okay, now brain is guiding the neural network, neuron system in the body that come on, go and heal it. That's it. So when brain finds that there is a problem in the neural system, then the most highest level of the abstraction in the neuron get a guidance that it has to heal somewhere. Then it finds where. Then that abstraction layer, where the actual problem is, then there it sends the signal and it heals itself. Okay? if I have a problem in muscular system, then brain gives the guidance to the muscular system, and at that particular layer of abstraction, it heals itself. Okay, if problem is in respiratory or circulatory system, it heals itself. So, but healing is different. A circulatory system cannot heal neural network. A neural system cannot heal respiratory. They know their internal healing on their own. Only thing is, first of all, they should heal themselves. But if they get the guidance, so guidance, the signaling, what we receive from the higher level, that is also in the abstraction. Okay? So brain says to the neural system that please heal yourself because there are problems. And if you say to the muscular system, please heal yourself, there are problems. Then muscular system again goes down the abstraction and it gives a similar guidance till it reaches to a layer where the problem is and it heals it. But from the top, only instruction comes as abstraction, please heal. But the actual healing happens differently than system to system. So like builder design, when we create anything, and when we order, like if I am standing in the restaurant, and then I am giving order to prepare something, then the person who takes the order, he doesn't know anything. Okay? And he takes the order. Then he passes the order to another guy. Then the guy, he dissociates, he disassembles the order, then passes it to different departments. And those departments, then they may pass to other department and they actually make the product. Okay? So, a department who is filling kind of chocolate, so he feels that the person who is receiving the order is passing to another person. He feels that here some filling is required. He sends it to filling department. Now filling department, actually he thinks I have to fill it here, the chocolate or the milk product or any whatever. Then if it is chocolate, then it may go for another abstraction where it is a choco or cocoa. I mean, I never eat chocolate or whatsoever. So this way. So the instruction what comes from the top, it is also in the abstraction, but it follows builder design pattern. And then it goes to the respective layer, and finally the actual work happens through that abstraction. So we talked about the requirement of the designing a software. It should eat minimum electricity, and then we went to kind of a layered approach where each layer, except the downmost layer, each layer is abstraction, and they exist on their own, and they have high internal energy. And then slowly they work on their own. And maximum, if they receive the hint or signal from the outside, then they change their movement. Otherwise, they work on their own. So that higher level, they should continue their work, what they are supposed to do. And then, so this is the food, what they are eating. And they don't expect food from outside, they only expect the instruction. Next we saw, so there we see the flyweight design pattern, and then we saw that instructions should also come as an abstraction, signaling should also come as an abstraction, and each layer they should follow the kind of builder design pattern to build the actual thing. So we made the software, means we designed the software. We can design our body like that also.